center of gravity, an imaginary point around which body weight is evenly distributed. The center of gravity of the human body can change considerably because the segments of the body can move their masses with joint rotations. This concept is critical to understanding balance and stability and how gravity affects tennis techniques. Let's look at Novak's forehand here. Notice Novak's center of gravity as he jumps to unleash his heavy forehand. Another great example is Roger's center of gravity in this video. As you can see, it's quite low as he sets up to execute this neutral backhand. As you can see, Novak's athletic posture before returning the serve indicates a well-balanced center of gravity. Balance. A player's ability to control their equilibrium or stability. There are two types of balances that coaches need to be aware of. Static balance, the ability to control the body while the body is stationary. Novak is one of the best returners the sport of tennis has ever seen. As you can see in this video, his athletic setup and posture before the return of serve is an example of the correct static balance. Dynamic balance. The ability to control the body during motion. Carlos Moya, one of tennis' most effective movers, demonstrates great dynamic balance as he returns this serve and then gets into the right setup to meet the incoming shot from his opponent. Inertia. Newton's first law of motion. The tendency of the body to remain at rest, or a body in angular or linear motion to remain in motion unless disturbed by an external force. Inertia is a characteristic of an object that resists changes to its state of motion. Inertia indicates how much force it will take to cause a particular acceleration or deacceleration to an object. A great example of inertia is Tomas Berdych approaching the ball. In the ready position, Berdych overcomes resting inertia, and through muscular contractions, he is able to accelerate towards the ball. Another example can be seen in Roger's forehand stroke. After impacting the ball, his racket rotates around an axis as it travels across his body and eventually deaccelerates, causing it to end the swing path at shoulder height. Opposite force. Newton's third law of motion. For any action or force, there's an equal or opposite reaction or force. In this example, Roger demonstrates a beautiful one-handed backhand with two forces going in opposite directions. The same is evident in Stepanik's backhand volley. Look at the arms going in opposite directions. Another great example of an opposite force being used is Roger's serve, as his tossing arm is pulled downward with great force, while the hitting arm accelerates upward to the ball. Momentum. The strength of force an object has when it's moving. Momentum in tennis occurs in the form of linear and angular vector quantities. In momentum, we can focus on the energy the body creates. Linear momentum. Momentum in a straight line, either horizontally or vertically. Tomas demonstrates a great example of linear momentum in a horizontal vector when approaching this ball. Angular momentum. Momentum created by the rotational or circular motion of the body and various body segments. Novak's body demonstrates both angular momentum while his body rotates to impact the ball, and linear momentum in the vertical vector as he leaves the ground during this forehand stroke. Elastic energy. It occurs when objects are compressed and stretched, or generally deformed in any manner. In terms of tennis, the ability of the body to perform work due to the energy stored as a result of stretching the muscle. All strokes have two moments from a mechanical point of view: pre-stretching and releasing. During any split step, a player like Carlos Moya stores energy in his legs so that after landing, he can use an explosive first step towards his next shot. Kinetic chain. The parts of the body act as a system of chain links, whereby the energy or force generated by one link or part of the body can be transferred successfully to the next link. The optimum coordination or timing of these body segments and their movements will allow for the efficient transfer of energy and power up through the body, moving from one body segment to the next. Each movement in the sequence builds upon the previous motion, and they all contribute to the generations of racket speed. Roger maximizes the effect of the body's kinetic chain in his service motion. As we can see, he uses energy from the ground and transfers it through the leg drive all the way to the hand flexion when executing this well-timed stroke.